Alright, so this was the first question that we have. You can see the arrangement. We have metal rails. On the metal rails we have a metal rod, and underneath that we have row of magnets. So we have placed magnets in a line. And the question is, explain what happens to the metal rod AB. And that question is of 4 marks. Okay, so you gotta write at least 4 independent pointers just to be on the safe side. So once you have mentioned the direction of current on the rod, by considering the fact that the lower end is a positive and the upper one is the negative, and hence the direction of the current is from positive towards the negative. Alright, this is the direction of the conventional current, and this is the direction of the current which flows in the conductor. So for 1 mark, for the first mark, you write current flows through the rod producing a magnetic field. We studied that in a topic that whenever current flows through a conductor, it produces a magnetic field. Now for the second mark, you write this thing: this magnetic field interacts with the magnetic field of this row of magnets. Right? So one of the magnetic field is due to the current flowing through the conductor, and the other magnetic field is due to these rows of magnets. So these two magnetic fields interact with each other, and in consequence a force is produced which is in accordance with the Fleming's left hand rule. Right? Fleming's left hand rule gives you the direction of the force, and in this situation, if you apply the left hand rule, direction of force would be towards the right side. So this is how you get 4 marks on this one. You can write as many independent pointers as you can just to be on the safe side, but at least you need to write 4. Okay, moving on to the next one. This diagram shows the construction of a simple loudspeaker. A coil of wire is wrapped around a paper tube attached to a loudspeaker cone. When there is an alternating current in the coil, the cone moves. Describe how the alternating current generates a sound wave. You may draw a diagram if it helps your answer. So this is basically the working. They have asked you the working of the loudspeaker, and you have to explain the working of the loudspeaker in this one. Right, so we studied that in detail. We completed the circuit diagram as well, but here I'm just writing 4 key pointers. So the first thing is, like they have stated, we are using alternating current. What does that mean? It means the alternating current would be producing alternating magnetic field. Alright, so this was the first pointer. So the next step we can write, when there is a changing magnetic field and there is current passing through the conductor, a force acts on the coil. So changing magnetic field. So this changing magnetic field would produce force on the coil. And once the direction of the current changes, the direction of the force. So if you change the direction of the current, which is going to happen because it is alternating current, it would keep changing the direction automatically, periodically. So we can write as Alright, so these are the 4 key pointers that explain the working of the loudspeaker. AC current, alternating current produces the changing magnetic field. It'll give rise to a force, and the direction of the force would also change because the direction of the current is being changed. and as the direction of force changes periodically, the coil and the cone would also move back and forth periodically. And as it moves back and forth next to the coil, it would give rise to the regions of compression and rarefaction, and hence the sound wave would propagate. So all in all, that is basically the steps that we have written already for the loudspeaker. Okay, here we have the next one. A student uses this apparatus to investigate electromagnetic induction. When the south pole of the magnet is moved in the coil, the pointer on the sensitive ammeter moves to the left. So this is the magnet. So if you bring the magnet inside the coil of wire, towards the coil of wire, the sensitive ammeter moves to the left, which means there is a positive induced EMF. There's positive induced current on the meter because the left side is representing the positive. Describe 2 ways that the student can make the pointer move to the right. Alright, very easy question. What they are asking is, how can you change the direction of the induced EMF? So what you can do is, if you're pushing the magnet towards the coil and you do the reverse of it, the direction of the induced current would be changed. So number 1, pull the magnet away from the coil. Pull the magnet away from the coil, and then you have to write one more pointer. So what if you reverse the magnet? You place the magnet upside down. So right now, as I take a look at the magnet, the north side of the magnet is close to the wire. What if you place the magnet like this? So south here and north here. That would also reverse the direction of the induced EMF. So what you can write is, reverse the direction of the magnet. Alright, so first one, pull the magnet away from the coil. The direction of the ammeter deflection would be reversed. And reverse the direction of the magnet. You place the magnet like this, south here, north here, then you try to bring it in. In that case also, the direction of the induced current would be changed. Alright, anyway, let's move on to the next one. A student has a bicycle with a generator that supplies electricity for its lights. The diagram shows the dynamo. The friction wheel W presses against the bicycle tire. When the student pedals, the friction wheel turns and causes part Y to rotate. What is a part Y and what is a part X? Part Y is the central part, which here we have the permanent magnet. Permanent magnet. And this one, this part is a coil that is also called as armature. Okay, so complete the key for the diagram by giving the names of part X and Y. Already done with that. Let's move on to the next one. The graph shows how the output voltage of the generator varies with time as the student pedals steadily. State the maximum output voltage of the generator. So we just need to read the graph from here. So check it out. You have 1 volt here and 2 volt here, and between 1 and 2 volts you have 5 small blocks. That implies each block is representing 0.2. So here you have 1.2, 1.4, and this one would then be 1.6. So you can write here, this one is 1.6. So the maximum output voltage, either you can write plus 1.6 or negative 1.6, whatever you want to. Unit is already there. The next one is calculate the frequency of the output voltage. So frequency simply means the number of waves in 1 second. Now in this one, it is slightly difficult for you guys to directly calculate the frequency because you don't know how many waves are there in 1 second. Matter of fact, 1 second is not even shown here. So what you can do is you can find the time period, and from time period you can find the frequency. How do we find the frequency from time period? Once you have the time period, all you have to do is to do 1 hour of time period, and that gives you the frequency. Now the thing is, how do we find the time period first? Time period means the time that has been taken by one complete cycle. So you see, one wave is being completed till here. And how much time? 0.04 seconds. Right? For the single wave cycle, is taking it 0.04 second. So the time period is 0.04 seconds. Now you can find the frequency mathematically from here. Frequency equals to 1 over t, and that would be 1 over 0.04. And if you hit it on the calculator, it will be 25 hertz. So that means in 1 second there would be how many waves? 25. So there's another way also. If you don't want to find the time period first, you want to find the frequency directly. You see how many waves are there in 0.04 seconds. So in 0.04 seconds, so here I'm writing seconds and here I'm writing waves, number of waves. In 0.04 second you have 1 wave. So in 1 second you'll be having how many waves? We put x here, then we cross multiply, and that gives you x equals 1 over 0.04. And some of you guys would realize that it is just the same thing. Don't you see, it's just the same thing? T equals to 1 over f, and this is basically the same thing, the same formula we are using, but the apparently it might be looking different. Are we clear with this? Okay. So which row of the table is correct when the friction wheel turns faster? So I told you, if you increase the speed of the generator, speed of rotation of the generator, there are 2 changes that take place. So on the workbook of electromagnetic induction, there is a separate page dedicated to this pointer. A separate page for this one. If you increase the speed of the motion, there are 2 things that are being changed: the amplitude as well as the frequency. So this will be the right answer. C. So amplitude increases and so does the frequency. And if you reduce the speed of the generator, amplitude decreases and so does the frequency. There are 2 changes that take place due to this effect. Okay. Apart from changing the speed of the friction wheel, suggest how the output voltage of the dynamo can be increased. A very easy one. There are plenty of ways that you can do it. One of them is you use a strong magnet. Use a stronger magnet. All right. Other than that, increasing the length of the conductor, which in this case would be use more number of turns. All right, moving on to the next one. The storage cycles for 290 seconds. Okay, this is the total time. The dynamo produces a constant useful output of 3.1 watts and is 72% efficient. Okay, and is 72% efficient. So what we need to find is calculate the useful output voltage. Useful energy output. So first of all, energy equals to, you should realize formula for energy is power times time, P into T. Energy equals to PT. All right. So what is how much power do we have? The power that we have is 3.1. All right. This is the useful one. So we have the useful power. We multiply it by 290 seconds. We don't do anything with 72% in this part. No, because for output energy, all we need is the output power and the time. And this itself is the output power. The effect of 72% is already included in it. So if I hit it on the calculator, you get 819. We can write it as 900 watts. 900 joules, sorry. The unit is already there, given. State the relation between the efficiency, useful energy output, and the total energy output, input. So efficiency equals useful energy divided by total input energy. Useful energy divided by total input energy. Alright, then in the next part we have to calculate the total energy input. So whatever the total energy input was, the total output is 900 joules. Okay, let me explain this one here. The output, useful output, is 900 joules. 900 joules, and the input energy, all right, input energy is unknown. We don't know how much input energy is, but what we know is that this useful output was 72% of the total energy. Whatever the total energy was, the output energy was 72% of the total input. So this is a question of reverse mathematics. If you want to use the formula of the efficiency, you can. You're very welcome to use it. Otherwise, you can use the reverse percentage method also. So 72% of the energy is 900. How much 100% would be? and then you cross multiply this one with this one and this one with this one. So what you get is x equals to 91234 divided by 72. And if you hit it on the calculator, let me just write on the calculator. (91234) divided by 72, 1250. In 1250 joules. All right. You want to round it off to two significant figures, you can. Otherwise, you can leave the answer as it is, 1250 joules. So if you want to apply the formula of efficiency here, you'll be getting the same answer. Either way, you'll be getting the same answer.